morning all of you. Today we will see next point, that is hard and soft acids and bases, which is called as the HSAB concept. Now when we have taken HSAB concept, this will be taken on the basis of hard and soft when we have taken acids and bases. Now we have seen that is 4 points in case of the theories, that is concepts of acids and bases. Now these concept can be helps to study as concept to HSAB concept. Now in case of HSAB concept, if suppose we have taken here that is the metal ions, you can say metal ions, suppose we have taken as this will be Ag plus. Ag plus is a metal ion. This can be acts as the acid. Again suppose we have taken NH3, it is called as the ammonia, it is called as the ligand. Ligands are acts as the base. Now this concept can be comes in case of the Lewis bases. Lewis bases can be, this concept helps that to study the acid base reactions, which is called as the neutralizations, and it is also called as the formation of the complexes, coordination compounds. This will be, if suppose Ag plus twice NH3, you can say here that Ag NH3 twice. Now this is called as the complex, and this complex when forms, that time here acid base reaction can be takes place. And again the stability of the acid base complex, this can be taken as concept to complexes, and this concept is called as the HSAB, means hard and soft. When comes together, how the combination can be takes place, this idea can be explained in the this concept, which is called as the HSAB concept. This concept is first of all explained by scientist Pearson. Pearson's HSAB principle, it is also called as. The starting of the study of the HSAB concept was taken as concept, that is Irving Williams. This is the first scientist who have discovered in 1953 the stabilities of the complexes as concerned to increasing orders. Suppose we have taken the complexes of the Ba2 plus, Sr2 plus, A2 plus, Mg2 plus, Mn2 plus, Fe2 plus, CO2 plus, Ni2 plus, in the increasing order as concerned to the stabilities. Stabilities can be increases when we have taken from Ba2 plus to Zn2 plus. Why the stabilities can be increases as concerned to complexes? This can be explained by the scientist Irving Williams in 1953 on the basis of the decreasing size of the cations. The size can be decreases from here barium 2 plus to Zn2 plus. Here barium possesses very high large size, whereas Zn2 plus possesses very small size. When the small size Zn2 plus can be taken, it can be formed as a highly stable complexes. Now this idea can be given by the scientist Irving Williams in 1953. Again another 3 scientists comes together. Now when we have taken here Irving Williams, here so many molecules, so many ions can be explained. Suppose we have taken here Ag plus, platinum 2 plus, Hg2 plus. Now these ions can be formed as a complexes. In case of, that is, suppose we have taken as totally filled electrons in case of the d orbitals. Again sometimes what happens, if suppose cobalt 3, iron 3, these metal ions possesses high oxidation state, there will be vacant orbitals will becomes, no electrons in the d orbitals. Such complexes can be formed. This idea can be comes in case of the Irving Williams explanations. Now again what happens here, if suppose we have taken 3 scientists, one is that is in 1958 S. Ireland, J. Chat, N.R. Davis, they can be explained, that is the HSAB principle. In case of HSAB principle, that is hard and soft acids and bases, they can be classified in 2 parts. Suppose we have taken an acid. Now this acid can be classified in the class A, you can say hard acid, class B soft acid. Now again you can say here that if we have taken base, hard base, soft base. Now in this way classification can be given by the scientist, three scientists, Ireland, Chat and Davis, on the basis of the, you can say, which metals will be comes in case of the hard acids, which metals will be comes in the class B. It is called as the soft acids. Now generally in case of the class A, the class A consists of the alkali metals, means first A group elements. In case of first A group elements, if we have taken as the H plus, Li plus, Na plus, K plus, all these elements will be called as the alkali metals, alkaline earth metals. They can be started from Be2 plus, beryllium 2 plus, calcium 2 plus, magnesium 2 plus, strontium 2 plus. Now these idea can be explained on the basis of, you can say, alkaline earth metals. Now again what happens in case of that is lighter metals. When we have taken lighter metals means small size, high positive charge. The metals which can be possesses titanium 4 plus, Fe 3 plus, cobalt 3 plus, chromium 3 plus. These are called as the, you can say, lighter elements because they can be possesses small size, high positive charge. Now this will be comes in the class A. Again class B consists of, here the metal ions which will be possesses, you can say, very large size and again you can say small charge. Small charge, large size, these are the ideas as concerned to class B, which will be called as the soft acids. Now this idea can be taken. Now in this way class A and class B, these are the taken as concerned to acids. Also class A, class B for the bases. If we have taken as the base, when the base can be react with the class A elements, this is called as the class A base. Again class B, when the molecules can be combined with the class B metal ions, these bases are called as soft bases. Now this idea can be comes in case of, you can say, generally hard and soft acids and bases, which is called as the HSAB concept. Now again HSAB concept can be starts with the classification of acids and bases as concerned to hard, soft and border lines. Now suppose we have taken here, generally what happens here, this will be BH. This can be combined with CH3 Hg plus. Now generally what happens here, this BH plus can be taken and both combined together, that time it is found that CH3 Hg plus, again you can say H plus will be comes here and again what happens, B will be goes outside and therefore what happens here, this is a soft base, this H comes here, the meaning can be taken, how the basis here, classification will be taken. How the classification can be taken as depending upon the size, again charges, here that is the classification can be taken. Hard, borderline, soft. When we have taken as the hard, I have told here that is all the alkali metals, alkaline earth metals, they will become in the hard acids. Borderlines, 2 positive charge, again iridium, ruthenium, again rhodium, they will become here. Soft means I have told here that they can be possesses large size, small positive charge. Now generally these metals can be taken in case of all the metal ions, all the cations, they can be plays very important role to act as the acids. Soft acids, hard acids, borderlines, they can be taken. Now again it should come to us here, hard base, borderline, soft base. Suppose we have taken here that Cl minus, F minus, OH minus, who possesses high electronegativity. Now generally they can be acts as the hard base. Again borderline means here borderly, this will becomes again soft base, H minus, I minus, HS minus, here that is negative charge will becomes cyanide, thiocyanate, sulfides, they can be acts as the soft base. Now generally here some definitions can be taken as, suppose we have taken as the hard acids, which are the substances? The substances which possesses high positive charge. Again you can say high positive charge, very small size, high positive charge, less polarizability. These are called as the hard acids. Again softer, they will be opposite to hard, means here that is the cations which can be possesses large size, small positive charge, high polarizability. These are called as the soft acids, and these are the border medium. As concerned to size, as concerned to charge, all they will be comes as a medium. Again, medium polarizability. All the cations can be acts as concerned to hard border lines, again soft, and therefore this idea can be taken here. Again, hard base, borderline base, soft base. That is, if we have taken hard base, they can be defined as, when we have taken here, that is ligands. The ligands which can be possesses small size, high negative charge, and again that is, you can say, less polarizability. These are called as the generally hard base. Again, you can say soft base. Soft base can be taken here, generally large size, small charge, again high polarizability. This idea will be taken in case of soft base, and generally this classification based on the cations. Again, you can say anions. Anions means ligands. Cations means positive charge containing, you can say, cations. Cations and anions, when brought together, they can be combined to each other, and formation of, you can say, a complex can be takes place. The formation of the complex, this can be well explained on the basis of Lewis concept, where the hard and soft idea will be explained. Now, generally, the HSAB principle can be tells that the statement of HSAB principle is that hard acid always prefer to bind as a hard base. Soft acid always prefer to bind as a soft base. Means the hard comes together, soft comes together, they maintains the stability of the complexes. Stability of the complexes depends upon the HSAB principle. HSAB principle tells that hard acid always prefer to bind as a hard base, soft acid always prefer to bind as a soft base. That is, soft combines together, hard combines together. Now this idea will be explained in case of HSAB concept, HSAB principle. Scientist Pearson, he have given the information about the formation of the complexes by taking of cations and again here ligands. These are the classification based on the, you can say here, that is the charge, size, polarizability as concerned to cations, anions. This classification is called as, you can say, on the basis of HSAB principle, the classification of hard, soft and borderline acids and bases can be taken. This can be represented as like to this. Now today we will stop here. Next lecture, next point we will study.